My name is Jacob Kelter, and I'm the director of the NetLogo Center at Northwestern University. In this video, I'm going to explain a little bit about what NetLogo is and how it can be used in education. NetLogo is a software for something called agent-based modeling, which is used for modeling and understanding scientific phenomena of all types across the natural and social sciences. So I have an example here of an agent-based model of an ecosystem made up of wolves, sheep, and grass. So those are the three agents in this model, and they each follow some simple rules. I'll go ahead and start running this. So the wolves, their rules are that they wander around and they eat sheep. If they get enough energy, they reproduce, and if they run out of energy, then they die. The sheep wander around and eat grass, and they also reproduce. If they get enough energy, they die if they run out of energy, and they also die if they get eaten by the wolves. And the grass just periodically regrows. And from these simple rules, we get these very interesting population graphs over time, which look very similar to the cycles of populations that we see in real ecosystem data. And these cycles emerge from the interactions of the agents, but they're not directly programmed into the model. This idea of emergent patterns or emergent phenomena is very central to agent-based modeling. Now, educationally, students can get really actively engaged in exploring the model, asking questions, and answering them by experimenting with the model, changing these parameters over here, and maybe even modifying the code of the model. Okay, here's another example, this one from chemistry. This is a model of an ideal gas in a box. And so the agents here are molecules that are floating around and bouncing off the walls, and we measure the pressure based on how many collisions are happening with these walls. I'm going to go ahead and speed this up. And in this model, it's connected to this data analysis program called CodeApp, which is made by the Concord Consortium, and it's collecting data after each run. So if I change the initial wall position here, when I click setup, you'll see this wall move out. So we've changed the volume, and we run this again. When we get to 30 ticks, 30 time steps, we'll get another data point over here. And so students can use this to very easily plot a bunch of data from the model and then try to discover the ideal gas laws on their own. Okay, I'm going to show a few other quick examples. This is a physics model. This is a model of current in a wire. So the agents here are electrons, and you can see them that they are flowing through here and they get deflected by these blue circles, which represent nuclei. And from this model emerges the relationship between voltage and current and resistance. Here's another physics model. This one is of a simple spaceship. And with this one, students can get engaged in some simple block-based programming without needing to do text-based programming. So this little blue square represents a spaceship, even though it doesn't really look like it. And the goal is for students to try to get it to fly and stop on this green box over here. So if we go ahead and put this left engine block in here for 11 seconds and click setup and go, we'll see that engine turn on and the spaceship flies off to the right. So to solve this, students really need to understand Newton's laws at a conceptual level. And these blocks have NetLogo code inside of them, but they're made at a level that students are engaging with the scientific ideas and not having to worry about the details of the programming language. So this is one way to engage students in problem solving and computational thinking and programming while also learning about really important scientific topics. NetLogo is used in social sciences and the study of various human systems as well, not just the natural sciences. This is just one example, and it's a model of a traffic jam. So the agents here are cars, and they follow the simple rule of speeding up until the speed limit, unless there's a car in front of them, in which case they slow down. And we get this emergent traffic jam. You can see here this traffic jam is formed, and it's moving in the opposite direction of the cars. And this can be confusing to people because people think, well, the traffic jam is made up of cars and the cars are moving left to right, so the traffic jam must move left to right. But the traffic jam is not the same thing as the cars. It's an emergent pattern made up of cars. And that emergent pattern can have very different behavior than the cars which make it up. There's a lot of other models in the NetLogo models library of social science phenomena, including models in economics, politics, and sociology. And NetLogo is also used in dedicated computer science courses. So this is one example of a more sort of computer sciencey model called a Cellular Automaton. And in this case, the agents are these little squares, and they have a rule of deciding whether to turn black or yellow based on the value of the three squares right above them and to the left and right. And depending on the exact rule of how to decide whether to turn black or yellow based on those three squares above, these really interesting patterns can emerge. So that's a broad overview of all the different types of things that can be modeled using NetLogo. And students can get really actively engaged in exploring models, programming them with blocks like I showed in that spaceship example, or even engaging with the text-based code of NetLogo. NetLogo is designed to be quite easy to understand, so students can start by just reading the code to understand how exactly the model is working. And then they can progress to modifying the code and then making models from scratch. And the fact that NetLogo code is easy enough for students to engage with and that it's always available is one thing that makes it stand out compared to many science simulations which don't reveal the underlying code to the learners. There's also a version of NetLogo called HubNet, in which students can actually control an individual agent. So each student in the class is connected through the internet, they're each on their own computer, and they each control one of the individual agents in the model. And that's called a participatory simulation, where each student is participating as one agent in the model. And that can be a really fun way to get the class engaged in trying to understand a phenomenon and how it emerges from all of their collective interactions. So that's a broad overview of NetLogo, how it can be used in education. And if you have any questions, feel free to reach out to us. There will be contact information in the description below.